Hello students, welcome you all. Today's session we will share about coordinate geometry for class 10. You know our syllabus of coordinate geometry in class 10 consists three different exercises. First one exercise is related to distance formula. Second one is related to section formula, and the last one is related to area of triangle. So let us start today's session with the derivation of distance formula. Here student, what actual is, we have been given 2 points, say A and B, with their coordinates. For point A, x1, y1, and for point B, it is x2, y2. Now we have to find out the distance between these 2 points, which is AB. So the formula for this AB distance is under root x2 minus x1 whole square plus y2 minus y1 whole square. Or we can write the result in this way also: distance equal to under root x1 minus x2 whole square plus y1 minus y2 whole square, because you know x2 minus x1 is not equal to x1 minus x2, but their squares are equal. That's why we can change the order of these coordinates in the formula. As per our convenience, we can write either under root x2 minus x1 whole square or under root x1 minus x2 whole square, plus similarly for second, y2 minus y1 whole square, or we write y1 minus y2 whole square. You can also write in this way also, that one square, say x1 minus x2 whole square under root, plus in another you can write first y2 then y1, so it is y2 minus y1 whole square. That makes no difference because there is a square, and on squaring the minus of two coordinates are equal in both the cases. Either we say x2 minus x1 whole square, or we say x1 minus x2 whole square. Okay students, so let us drive this result, how this result comes. Now let us see here in this adjoining figure. You see here point A and point B is given with their coordinates x1, y1 and x2, y2 respectively, and we have joined this point A and B by a line segment AB. So we have to find out the distance of this AB. Okay student, now for this what we will do, in the Cartesian axis we draw perpendiculars from this point to x-axis and y-axis, as it is drawn here. From A, AC, and from B it is BD perpendicular to x-axis, and similarly from point A it is AE, and from point B it is BF perpendicular to y-axis. You know student, A is having coordinate x1, y1, so from A the perpendicular will cut the x-axis at x1, that is the distance from origin to this point will be x1, and that is OC equal to x1. Similarly, the perpendicular drawn from point V whose x coordinate is actually x2, so it will meet x-axis at x2, that is OD equal to x2. And from these two distances we can have the distance between these 2 points C and D just by subtracting. So CD is actually equal to OD minus OC. So it is equal to x2 minus x1. Similarly, on y coordinate, on y axis, let us see, from A perpendicular meets at E having coordinate y1, so it shows that the distance OE equal to y1, and from B the perpendicular meets y axis at F point, indicating that OF is equal to y2 because B has y2 coordinate. Okay, student. Now from these two again we can find EF by subtracting. So EF will equal to y2 minus y1. Okay, student. Now let us draw another perpendicular from point A to BD meeting at point M. Okay. Since AC and BD are two perpendiculars drawn on the same line, so these two will be parallel. And between two parallel lines, the distance, perpendicular distance, are always equal. So this indicates that CD, which we have already calculated, x2 minus x1, that CD now is equal to AM. Okay, student. Similarly, on y-axis, what we have calculated earlier, EF, which was y2 minus y1, is now equal to BM. Is it clear? Yes. Okay, student. Now, after all these doing construction, that is drawing perpendiculars and calculating distance between points, now it's very simple to have the distance formula. Just considering the right triangle AMB. You see, at point M there is 90 degree as we have drawn the perpendicular AM to BD. So in right triangle AMB, AB, which is to be calculated, is actually, it is hypotenuse of this right triangle. So AB is equal to under root OM square plus BM square. Now we will put the values, then we will have it is equal to under root x2 minus x1 whole square plus y2 minus y1 whole square. In this way we have the distance formula, and since there is a square inside the square root symbol, so we can reverse it also. So AB can be written as x1 minus x2 whole square plus y1 minus y2 whole square. In this way, I think it is very clear the derivation, although it is not asked in examination to derive the formula, only questions of exercise related rider questions are asked in examination. Even then, if we learn this, then it is very clear that how formula has been derived. Okay, student. Now let us see some question based on this distance formula. For this, we just take the another page here. So some question I have written here. See the question first. But before going question first, again recapitulate your some notes which you have already done in your 9th class, but just reminding you that coordinates of origin is 0, 0, you know, and any point on x-axis has coordinate x, 0. Similarly, any point on y-axis has coordinate 0, y. Okay. Now let us take one question. Find a point on x-axis which is equidistant from 2 points A having coordinate 2 comma minus 5 and B having coordinate minus 2 comma 9. So according to question, we just draw a rough sketch. Here the point P, which is equidistant from given two points A and B, as you see here, and A and B has their own coordinate. Since P point is on x-axis, and just we have seen above, any point on x-axis has coordinate x0, so we write here x0. Now according to question, PA is given equal to PV. So if two things are equal, then their squares are also equal. On that basis, we write PA square equal to PV square. Okay, student. Now, although we have written here square, so PA is actually the distance between P and A, which is equal to under root x minus 2 whole square plus 0 plus 5 whole square. I think 0 plus 5, why it is, so it is actually y2 minus y1 or y1 minus y2, so 0 minus 5, that is 0 plus 5 whole square. Similarly, it is equal to PV, which is x plus 2 whole square plus 9 minus 0 whole square. So student, here since we have taken the square root symbol, so we cut it this step, because when we write square, then there will not be square root sign. So to remove square root sign, we used to take square. Since we have taken the root sign, so we don't see this step now. Okay, so according to question, PA equal to PB, and we have put the values for both the distances. Now it is equal to removing square root from both sides. Then we have relation this, on simplifying we get here x equal to minus 7. So our required point on x-axis it was x0, so now our point is minus 7, 0. Similarly, another question is, check whether the points given 5, 2, 6, 4 and 7, minus 2 are the vertices of an isosceles triangle. Here student, could you get the question? We have been given 3 points. Points given means, in coordinate geometry, point means coordinates are given. So 3 points whose coordinates are given, we have to check that whether these 3 points are the vertices of an isosceles triangle. So just imagine, if they will be the vertices of an isosceles triangle, then after finding its sides, that is length of sides, by using distance formula, say if we use the first 2 point, let it this be A and B, then the distance will be AB. Similarly, for last 2 point, which are B and C, then it is BC, and using A and C coordinate, we have AC. So in this way, we calculate using the above distance formula, and supposing that the given points are A, B and C respectively, and using distance formula, first of all we find AB by taking the coordinates of A and B. Then we find here BC by using the coordinate of B and C, and similarly using the coordinate of A and C, we find AC. Now we observe that AB here comes under root 37 unit. Here you see AB is root 37 unit, and now BC also comes root 37 unit, but AC comes root 4, which is actually 2 units. Now here we see that two sides AB and BC are equal, So it indicates that the triangle formed with two equal sides, so it is an isosceles triangle. So in this way we can verify it, that is, it is isosceles triangle. Similarly, one question is there that four vertices are given: minus 1, minus 2, first point, 1 comma 0, second point, third is minus 1 and 2, and fourth is minus 3 comma 0. These are the vertices of a quadrilateral, because there are 4 points. Now we have to find out which type of quadrilateral this is. For this, again we will use the distance formula, and supposing that these points are in order and named them as A, B, C and D. Now taking each 2 points, we find AB, which comes to root 2 unit. Here you see, here it is 2 root 2 units. Again BC is also 2 root 2 unit, CD 2 root 2 unit, and DA 2 root 2 unit. It means for a quadrilateral ABCD, AB, BC, CD and D are its side. It means all 4 sides are equal. So here, by seeing all 4 sides, which we have calculated using distance formula, this indicates that the quadrilateral is either a square or a rhombus. But now to particularize them, whether it is a square or a rhombus, for this we have to find out its diagonal, that is AC and BD. And how these two will be we can find just using the coordinate of B and D, and using distance formula we have BD. Similarly, using the points A and C, that is their coordinates, we can have the AC by using distance formula, and these two we have calculated, which are each 4 unit. So again these two are equal, and in case of a square the length of diagonals are equal, but in case of rhombus lengths of diagonals are not equal, whereas both the figures have all 4 sides equal. So now it is very clear, since diagonals are equal, so it is a square and not a rhombus. So in this way you can solve on that basis question related exercise, and I feel I hope that maximum question you can do. Even then some problem may be there, you search out this problem so that we may share in the next video, upcoming video. Till then, it's thanks, and have a nice day. It's okay, but don't forget to comment, like, share and subscribe. So till then, it's goodbye students. Okay, thanks.